Hey there everyone. In today's video, I'm going to discuss the topic of predictive analytics, and we are going to use a couple different regression models and classification models to make predictions after the model has been trained and see what the output is based on the training of the data. Okay, so we have an accuracy score, train test split, libraries that we're importing here, random forest classifier, random forest, AdaBoostClassifier, and gradient boosting classifier. So a couple different classifiers and a very simple data frame here. We have year, airport, casino, and then stadium and cost. Okay, now this is totally hypothetical. This is not real data. I just want to make a very simple, very streamlined example of a data frame where you're going to set the year as the axis. So the axis is going to be on the left-hand side. You can see that it's kind of pushed down a little bit from the headers: airport, casino, stadium, and cost. That indicates that's the axis of the data frame, right? If it was on the same level, then the axis would be numeric: 0, 1, 2, 3, 4, 5, and so on. So again, hypothetical situation, I'm saying if the airport has 2,000, let's call it seats, it could be 2,000 widgets, anything, and the casino has 5,000, and stadium has 9,000, the cost to build this thing is going to be 10 million. I'm dropping the M because machine learning models don't like letters or text. They like numbers only. So I'm going to leave off the M. I could put the M in, but I'd have to do a little data cleaning and drop it and delete those M's. So let me just start very simple and very easy and just assume that the 10 is M, 20, 20, 30 is M2. Okay. So we are calling the independent variables airport, casino, and stadium, and trying to predict the cost to build that thing based on the seating capacity, right? So the X variable is the independent and the Y is the dependent. So it's dependent on the independent variables. We're going to train, test, and split this data set. 80% for the training, 20% for the testing. We're using AdaBoostClassifier, okay? And we're going to fit the model with X train and XY. You can see that right here. And then we are going to make a prediction on the Y variable. Again, that is a dependent. And I want to measure the accuracy score between the Y test and the Y prediction. Okay, so very, very simple model, very simple setup, scenario, so on and so forth. So the model's been trained. The next thing we can do is take this classifier. Remember, we call the model CLF classifier. That's the abbreviation. CLF.predict, that's the property. And we're going to feed in these values now. 500, 10,000, and 15,000. Okay, and we're going to predict the target variable, which is the cost. If you look close, I can see that right here, 5,000, 10,000, 15,000. We should get an output of 30, okay, because the model has seen that. It should know that is going to be 30. Run the prediction, and there we go, we got 30. So that's great. My only concern is maybe the model memorized that because it's just a handful of records here. It's possible that can just say I saw the 5,000, 10,000, 15,000. I know the resulting record, the same record in the same row is going to be 30. So let's give it a scenario that hasn't possibly seen. It doesn't even exist in the data set. We want to see how well this model will generalize, and it can make the proper prediction based on airport, casino, and stadium combinations that has not seen. Okay, so let's go down here again, put in our predictive independent variables. So I have 5,000, 10,000, 10,000, 5,000, 10,000, 10,000. So that is pretty close to this scenario. That's 5,000, 9,000, 10,000. So that is similar enough. I would expect the cost to be 20. Let's run the predictive experiment here and see what it comes back with. Is it 20? Yes, 20. So we have 5,000, 10,000, 10,000. The model can't possibly have seen it because it doesn't exist in the data set, but it says this scenario 5,000, 9,000, 10,000 is close enough to 5,000, 10,000, 10,000. So I'm going to say the cost is 20 for that. So pretty cool, right? So that's one way of doing it. Now, making predictions on label data requires a little bit more effort because we have to convert those labels to numerics. Okay, so essentially a computer can learn and understand and work with numbers very quickly, much quicker than a person can. People can understand language and text and syntax and sentences and words much easier than a computer can, right? But we have to convert our non-numeric data into, or our label data into some type of numeric data or some type of categorical data, we can use LabelEncoder. It's abbreviated LE, OrdinalEncoder, OE. We can create category codes. We can do one-hot encoding. We can do a bunch of different things to convert this data set from labeled data into numeric data so the computer can understand it. So let's go ahead and run it. We have our did frame. Okay, so we have size, small, medium, and large. Okay, so the same scenario that we saw about the airport, casino, stadium, small, medium, and large. Instead of the numbers, now we have labeled data. Okay, so non-numeric. So we are going to go ahead and use the same independent variables for the x, the same dependent variable. What's the last one? The last one I think was cost. This is size, so it's called slightly different, but the implication is the same. And we're going to do a transform on that and do a feature encoding, okay, and then encode the target. So it's not labeled data anymore. It is numeric data, right? Okay, or categorical data, either one. As long as it has some type of number, this will work. Okay, so we trained the model. Here's the AdaBoostClassifier. We did the encoding. We did the fitting. Okay, we did the fitting right here, x train, xy. We did the encoding right here, and we're going to go ahead and make a prediction right here. CLF predict. CLF is classifier predict. I just ran it. Let me see what it says for prediction of EY. EXY. Okay. Okay, it says large, so that's good. We're in good shape there. Let's make another prediction. Again, it's slightly different than what we saw before because we're doing encoding now, and we fed in the 5,000, 10,000, 15,000, just like we saw before. We have this extra step because we have to encode the data. It's just not numeric, it's not straightforward. But if we have that combination, 5,000, 10,000, 15,000, what's closest to that? 5, 10, 15,000, large. That's why we get a large right there, okay? So that's the prediction. Let's look at one more case. Okay. Now, 5,000, 10,000, 10,000. Let's see what the computer comes up with. 5,000, 10,000, 10,000 is the independent variable features, okay? 5, 10, and 10. It says this is medium. Let's go find something similar above. What's closest? 5. There is no 5, 10, and 10. There's a 5, 9, and 10. That corresponds to a size of medium. And if you're paying attention, that's exactly what we got. We got a medium down here. So that's how you make predictions. You train the model, use the model name .predict. In this case, CLF predict. If it's labeled data, you have to encode it. We'll use one-hot encoder, LabelEncoder, categorical codes. They all work equally well. There might be slight pros and cons to one over the other. I like categorical codes or label encoding. One-hot encoding is okay. It has its time and place. I'm not a huge fan of that, just because if you have high cardinality data, you can explode the data set into many, many, many columns of data, because every feature has to have a 1 and a corresponding 0. And if you have high cardinality data like names, all the states in the United States, all the cities in the United States, and one-hot encode that, you're going to have a lot of columns, right? If you categorically encode that or label encode that, you'll just have one single column. So you can research that topic a little bit more. I think we answered the question of how to do predictive analytics using regression and classification. Hopefully that was interesting for you. Hopefully you gained a little bit of knowledge there during this video. I am going to go ahead and save this file as an HTML file and post it when I post the video. So you will have all the source code here. You can copy and paste this in your own Jupyter notebook environment and run it as is. And of course, take apart the code, disassemble it, pick it apart, reassemble it, understand how everything works, and of course feel free to customize it for your specific use case. So all you have to do is train the model and then call this model name. I use CLF predict. In this case up here, as we just saw, this is what do we call it? Let me see here. That's nice thing, CLF predict. But we didn't have to do the encoding here because these are all numeric. Okay, but you can call the classifier whatever you want. Do CLF.predict and you get your results. It's pretty cool stuff. So thanks for your time today, guys. Have a great day. Bye.